Hello all, I'm Animesh Mishra. I'm a solutions engineer at DiffBlue. I was a software developer for 10 years and specialized in application modernization. Today, I'll walk you through how DiffBlue AI can improve your code quality and accelerate your release cycles. This past decade in software engineering has been transformational. Confluence of cheap cloud compute, automated tooling, and widespread open source adoption has made software ubiquitous. We're hearing from devs that code bases have grown 5 times larger in the last 3 years alone. I asked around internally at DiffBlue, and we are averaging at about 3x. And now with AI code gen on the horizon, this trend of increasing complexity is only going to accelerate. But while development and deployment have become increasingly automated, software quality hasn't managed to keep up because unit testing remains a manual and resource-intensive exercise to this day. And this gulf in capability is exactly what we're going to address today. So DiffBlue, we work with companies like Cisco, SAP, and JP Morgan, and get to see how poor unit test coverage affects their day-to-day businesses. They face quality issues where an unacceptable number of production outages impact customer experience. Often they have aggressive delivery timelines and don't have the time to write high-quality unit test or need that time to improve velocity itself. And sometimes they're saddled with legacy applications which need to be modernized, but which they struggle to do because they don't fully understand how the applications work, and there aren't many unit tests there to begin with to help them do so. I'd love to know which out of these issues is most relevant to your organization. You should be seeing a survey out on Zoom about now, so please do respond. But that's where we are today, inundated by code, being asked to deliver ever more, and not much capacity to test it. So what options do we have as developers? The We could do nothing. We could keep going as we are and write test ourselves. They do have writing test ourselves does have the benefit of ensuring that the tests written are human readable, and well-written tests do have the side effect of documenting the application itself. However, as we've already discussed, the process doesn't scale well, and there are also wide inconsistencies in quality within teams and across teams when it comes to writing unit tests. Of late, a second option has emerged, which are code assistants based on large language models, LLMs. These code assistants, they will take the words in your code, try to match it with the words in their model, and they will send back some output at you, which may or may not be code. If you ask it to write a unit test, it may or may not be exercising the code under test. So often these tools do an excellent job of giving you a stellar boilerplate to start off with, but the developer has to spend time getting the output from these tools to the final outcome thereafter. So at DiffBlue, we ask ourselves the question, could there be a third way? Could we take the best of both worlds and make a solution that delivers human quality tests at AI scale? Turns out we could. So we did, and we patented it. We call it DiffBlue Cover, and it writes and maintains unit test suites for your Java applications. Unlike Code Assistance, it's a 100% autonomous tool. You do not need to babysit it. You give it a piece of code, click a button, and it analyzes your application and writes an entire test suite for you. DiffBlue Cover also works in your CI pipelines completely automatically. So it ensures that no code change, no commit, no PR goes untested. And most importantly, because we have a computational understanding of the code we're looking at, in places where we aren't able to write a unit test for you, we'll leave behind code quality insights, tips to developers to understand what could they do to improve the testability of that part of the application, so that when cover is run again, we will actually pick those improvements up and go ahead and write some more tests. So it's an iterative tool works with you within your software development life cycles, and improves and maintains coverage over time. And all of this AI goodness comes to you at no cost to your privacy or security. DiffBlue is a 100% on-prem solution. None of your code ever leaves your environment, and you always keep complete ownership of your source code and also the tests that DiffBlue produces for you. Let's see it in action. On my screen, you'll see a blue window, and that's my terminal. There's a browser open, which has the sample application we are going to be writing tests for today. And then I have the IntelliJ open in the background so we can have a look at the code and the test as well. DiffBlue covers ships broadly as the solution has broadly two parts. There's a command line interface, which is used to write tests at scale, whether locally on dev laptops, which is what we're going to do today, or in your CI working or getting triggered for each pull request. There's an IntelliJ IDE plugin as well, which is used to incrementally update your test cases. So when you use DiffBlue Cover for the first time, use the command line interface to write all the tests for the application in one go. We call these baseline tests, as they capture the baseline behavior of the application the day you adopt Cover. And from that point on, you have an AI managed test suite. And every time you make a code change, some tests will fail to alert you to the fact that a behavior in the application has changed, and you then decide whether that's an intentional or an unintentional change and act accordingly. If it's an unintentional change, then that test suite has helped you find regressions. And if it's an intentional change, then all you need to do is click that IDE plugin button, and it will go and update the test cases to incorporate the new behavior. So let's start off with this application we have. In my terminal, I'm at the root of this project. The application we're looking at today is called Pet Clinic. It's a sample application developed by the Spring Framework team to demonstrate the features of the Spring Framework itself. To ask Cover to write tests for the whole application in one go, all I need to do is be at the root of my application. So this would typically be where you have your pom.xml, the parent pom, and write the command dcover create. Cover will then start analyzing the application, identify all the methods that are present, and then we'll go write test method by method, class by class, until the whole application is covered. Like I said, don't need to babysit it, so we don't need this window here anymore. I am going to move that away and just look at the application itself. So in this here, what I'm most interested in is find pet owners form. So the Pet Clinic application is your standard MVC style application, model view controller. And the pet owners form allows me to search pet owners by their last name. Let's see how the form works, the different behaviors it exhibits, and then we'll see the best way to test it, and then we'll see how Cover has gone about doing it. So first thing first, if in this form, if I do not specify any search query and click find owner, I get returned with the whole database. So this is the empty string doing the broadest possible search, just spitting the whole database back at me in a paginated list. Cool. If I look for a name that doesn't exist, such as mine, we'll see a not found message. If you search for a name that is shared by multiple people in the database, you get shown a paginated list with all those Davises, and you can click through to their contact details. And finally, there's a neat little optimization built in where when you search for a name and there's only one person with that name, no point showing a paginated list with one. So we skip that paginated list and go straight to their profile page. So 4 distinct behaviors in this form. As a developer, if I were to write unit tests for this, I will make sure that each of these behaviors is accounted for in my test cases so that even the smallest of changes is picked up, and even the most benign of regressions is I'm alerted to when any change is made in the application later on. If we look at the code that powers this method, this process find for method is the underlying code that runs that search. And we can see it's got a few different code parts. There's this if clause that's doing the empty string, returning the whole database back at us. That's a not found case. Then we've got the paginated list when we have multiple items in the search result. And finally, when there's a single person in the search result, we have that optimization, and this is the code part that governs that. In the ID, I can see cover has found methods and it's plowing through all of the classes. So while it's doing that, let's have a look at how we go about writing unit tests. We don't use large language models in cover. We use a different machine learning technique called reinforcement learning. When you ask cover to go and write a test for an application, it's looking for the built bytecode to analyze. It picks that bytecode up and identifies all of the methods and classes that make up that application and how they're chained together to deliver the functionality that that application delivers. We call this data flow analysis, which allows us to understand the entry point in the application and how the call falls through across different methods and classes. Once we've understood all of that and indexed all of the methods that the application is made of, we'll pluck a method out and run it in an isolated sandbox environment. This environment allows us to observe the runtime behavior of the code, all of the effects and side effects it causes when it's run. Based on that analysis, we will predict an initial unit test. We run that unit test against this code running in the sandbox and measure things, metrics such as the coverage obtained, how readable the test case is, and a few other secret metrics that help us answer the question, is this a good unit test? If the answer comes out yes, we commit that test case to the project and move on to the next. If the answer is no, that test is discarded. We predict a better one and keep going through this loop 1,000 times a second until a great set of unit tests have been written for the whole application. And we're able to do this completely locally, on-prem, on device, about 250 times faster than a developer and 60 times faster than Copilot and other LLM-based tools. If we go back to my terminal, we are in owner controller, the Java class. I can see cover has finished writing tests for it. So let's go and have a look at our tests. So first thing that should strike you is just with a single command run in the IDE, Cover has produced a fully valid Java test class for us with all, not just the tests for the method we're looking at, but the whole class and then eventually the whole application. We know that this class works and all of these tests compile and run, but just to make sure that they do, I'm going to run this code with coverage. And what I'm looking for is to make sure that all the tests compile. So I don't need to go and make changes so that they compile, that they run and pass. And finally, that they actually test the method under test, which means they should give me a significant coverage as a result. So I do see that all of the tests that Cover has written here compiled, they run and they pass. And we also get a neat little 95% coverage right out of the box in a matter of seconds. So that's great. So far, so good. But all of this coverage is no use if the tests written are so poor that when you change the code, they don't catch that. Because ultimate goal of a unit test and ultimate redeeming quality of a unit test is a test that can help you catch regression. A unit test that doesn't catch regression is just as bad as not having a unit test to begin with. So I can see here that DiffBlue has gone and written 4 different test cases for a test find form feature. The first case is when we are not providing any search parameter altogether. So that's an empty string that's going to do the broadest possible search. I'll make it bigger. The second test case is when we have a single item in our search result and we saw a redirection happening. The third case is when we had multiple items in a search result and a paginated list to go with that. And finally, the case where we're looking for a name that doesn't exist in our database, the not found case. I'm going to focus on the middle two because these are the more interesting nuanced cases. So the first time when I saw a cover test, I was amazed by how readable it was. DiffBlue cover writes tests in the standard arrange, act, and assert pattern that we as developers use to write our unit test. So it's created some synthetic test data to start with, and cover ships with a limited dictionary built in where it is able to come up with plausible values for properties like city names, address, phone numbers, so on and so forth. But it also allows you to extend that capability and provide it your own specific test data to make the test more domain specific to your code. So we've created the synthetic test data. We initialized the application with that, and then using the mock MVC framework to drive the search and asserting on the behavior that we saw ourselves, which was when there was a single item in a search result, we saw a redirection happening to that profile page. And we can confirm that that's exactly what we saw by trying it out again. So we search for a person that we know only occurs once in the database, and we get redirected straight to their profile. And that's exactly what we see our test asserting on as well. So not only are the tests readable, not only that they compile, run, and pass, but the assertions that cover writes also reflect the runtime behavior of your code. And this is an absolute lifesaver when you're working with legacy applications, which you might not know much about. So you get viewpoint cover at it, get it to write a bunch of tests, and then by the way, by studying the unit tests it has produced, you start developing confidence about how that application works, and then you can start modernizing it piecemeal. The readability of the test cases also allow you to quickly review whether the code that you've written is doing the thing you want it to do. So if, say, for example, I had written a method here, which was doing redirection, and now I have a test case that demonstrating that behavior to me, but the functional requirement was something else entirely, anybody reviewing my code and then the assertions will pick up on that and say, are you sure this is what this code's supposed to do? And you will see this coming into picture later on when we talk about the CI integration and how Cover automates all of this within your PRs. But these are when we talk about that reinforcement learning loop where Cover is deciding whether test case is worth keeping or not, all of these factors go into that decision making to decide whether a test case is good enough or not. So to summarize it, Diplo will always write test cases, which will compile, pass, run, and reflect the runtime behavior of the code. If we look at the second case, where we had multiple items in a search result, again, similar kind of pattern in the test case writing, create some test data, initialize the application with it, and then use mocking frameworks to drive the behavior and then assert on the intended outcome. So here we created more test instances, and you'll see Cover is smart enough to create unique test data for multiple instances. So it's not just creating copies of Jane Doe's. You've created, initialized the application, and then again using the mock MVC framework to drive search, and now asserting on the pagination that we saw ourselves. So just to see it again, if we search for a name that occurs multiple times, we get a paginated list with multiple people in there. And that's exactly what we're seeing here in our test case assertions as well. So all my tests passing, which is great. They're reflecting how the application worked. Now let's go and make a code change and see if they are going to catch regressions. So I'll go back to my owner controller class. And you know what's going to happen when I change my code, because you've already seen how granular test cases cover writes. So what I will do is that redirection optimization that we have built in here, when there's only one person in the result, goes straight to their profile page, I'll get rid of it. So now it's just pagination throughout. As a developer, let's say my functional brief was to get rid of redirection, just put pagination everywhere. So I come to this code base for which somebody else, maybe a day before, has asked Cover to write all the tests. So now I have a Cover managed test suite in this application. Today, as a new developer onto this app, I've been given a brief that please remove this redirection behavior. So that's what I'm doing. And what happens, and you know what's going to happen when I run my test cases. So I've made my code change. Next thing I do is run the test suite to see if I've broken something. And if my test cases are written well, then I should see one or more failing, depending on the code change I've made. So lo and behold, we do see one of our test cases failing. If we look at the failing test, we can see it's the test case where there's a single item in the results asserting on redirection. I have swapped it out with pagination, so that is an entirely expected change. It's not a regression because I expected that test to fail. So at this point, all I need to do is I can now use the IntelliJ IDE plugin to update the test right within my work environment. I don't need to do any context switching. I don't need to go back to the command line. You can download the Diff Blue Cover plugin straight from the IntelliJ store. So you go settings plugin and search for Diff Blue Cover, and it should show up. Once you've installed it, you should see you have this nice little you get this nice little Flask icon on the left-hand gutter every time you open a Java source file or a Java test file. So in the test file, it looks like in the source file, it will look like a Flask with a plus icon. In the test file, it looks with a wrench. I click that wrench icon. I'm not going to ask you to update test for the whole class because I know there's only one test failing. So I'll just go and ask it to update the test for this method to incorporate the new code change I've made so that I can then push my PR and get this change merged. When you use the IDE, the underlying AI processes are exactly the same. Cover will kick off within the IDE, and then it does what we call pre-flight checks or environment checks. We look at the build system in use. We look at the Java version that's installed on the machine, the Java version that the project is configured with, and then the various frameworks for mocking, testing, and setting up the application that are in use in this project. We will look at that and create a dependency tree. Then we go to Maven Central and create a best known version dependency tree for all of these libraries as well, and then match the two. And if those two match, then you see a bunch of green ticks, which is what you see here. And if there are any internal incompatibility between some of your libraries, we will point that out as a warning. The reason we do that is because when Cover writes tests, it uses the exact libraries with the exact versions as specified in your Maven or Gradle configuration file. And if there are any incompatibilities between different versions of your dependencies, we might run into a situation where we can't write a test or we can't write as good a test as we would. So the pre-flight check is an excellent way of also ensuring that your project are configured with the best known configuration and are using the are set up properly. Once all of that is green, Cover then moves on to writing tests. So it's gone ahead and updated test for our method. So let's jump back to our test process find form method, and we can now see that in the case where there was a single item in our search result, that assertion has now been updated to show a paginated list, not a redirection, because that's exactly the code change that I've made. And that's how Cover not only allows you to create an initial set of unit tests for your application to guard against regressions, but also maintain them on an ongoing basis through the use of command line, the IntelliJ IDE, and the coolest and my favorite feature of all, the CI integration. And the way that works is we have it will sit in your PR process, and every time you open a pull request, Cover will come in and say, aha, I see a code change. Great. I'm going to run existing test and remove any non-passing tests. So that's exactly what we did. We ran the test locally and we found one failing test. And then I'm going to update the tests that need to be updated to account for the code change submitted, which is exactly what we did as well in the IDE by asking the plugin to update the test for the method. And so as a code reviewer, you see two things. You see the code change that I have submitted as a developer, which is my one-line change, removing the redirection replace the redirection with pagination. And you see the corresponding change in the application behavior by way of changes in the test assertions. So if we look at this assertion diff, we can see that what used to be a redirection is now a pagination, which is exactly what our functional brief was. So the code works as intended. It is written in a style that we want, and all tests pass. Check, check, check. I can merge this code and BMPs that I've not broken anything, and any new behavior that I've introduced has been accounted for in my test suite. And that is Diff Blue Cover in a nutshell. Here's what we did in the demo. We used the command line interface to write test baseline on the mainline branch. Then we made a code change. We used the plugin locally to update our test cases. And you can get the same behavior in your pull request by the way of a CI integration, where after you open a pull request, Cover comes into the picture, runs the test, and updates them as needed. So that at pull request, you're presented with the question, here's the code, here's the resultant application behavior. Is that what you're after? And if the answer is no, then the dev needs to go back and sort it out. And if the answer is yes, you merge the PR, get it out to your customers, and laugh yourself to the bank. We also saw different ways of using Cover. So there's an IntelliJ plugin, which we saw, and that takes care of what we call the inner loop of your development. So that's the developer working on the dev laptop, making the changes and building the code as they go. So for that inner loop, we have the IntelliJ IDE plugin, which provides the best developer experience. You can, of course, use the command line like I do sometimes locally because it's got more features, but the IDE plugin does the job 99.99% of the time. And unlike other tools, Blue does have a command line interface, which actually works completely automated and unsupervised in the CI as well. And the CLI is what we use in our CI integrations, as I showed you on GitHub. We have one-click integrations already available for GitHub Actions and GitLab. And if you're using other CI platforms such as Jenkins or any other, as long as the CI platform can run a command line interface, which all of them can, Diff Blue can run on them. So how are people getting, what are our customers using Diff Blue for? For a variety of things. We talked about the issue they're facing around the quality. And Cisco, one of our big customers, they are using Diff Blue Cover on an IoT application that manages 250 million IoT devices at one time. They bought in Diff Blue because they were seeing a lot of production outages, and after adopting Diff Blue, the production instances have gone down, and Diff Blue is helping them battle test 6 million lines of code across that IoT platform. Similarly, we work really well with Goldman Sachs, who had developer velocity challenges. People weren't getting time to write tests for the code they were deploying, and so they were getting also the corresponding technical problems with that. So they adopted Diff Blue Cover on a monolithic legacy application, and the test suite produced by Cover allowed them to start refactoring their code, and they were able to save about a year worth of developer effort full time. They were able to do that using Cover in about 8 hours. And and then we had worked with a customer, Raytheon, which was working with a public sector customer to move their entire estate to the cloud. And to do that, you need excellent level of testing because you need to be able to prove that whatever you've moved from on-prem to cloud works exactly as it used to. And given the deadline they had, there was absolutely no way they would have achieved that using the manual route. So they deployed Diff Blue on that estate and were able to actually complete the modernization project on time and under budget. But one of my favorite cases is from Citi Investor Group. So they had this legacy platform, which was actually impeding them from growing their business and getting products out to customer faster. And they were seeing themselves lag behind their competitors. So what they needed was modernization, but not just modernization, but quick modernization at scale. So we work with them to roll out Diff Blue across 2,000 developers, and they are now seeing significant improvement, not just in velocity and reduction in incidents, but also developer happiness. because developers are now getting time to work on the more higher value items in their backlog. They can offload the tedium of unit test writing to AI, and that was always what the AI promise was supposed to be. AI was supposed to do all of the tasks that we don't want to do, so we can then spend our lives doing the things we like. So we started the discussion today asking, okay, we can write test ourselves, we can use code assist and LLMs, but is there a third way to go about achieving what we want to do? And that is to write human quality test cases at AI scale. And yes, we can using DiffBlue Cover. It writes human readable tests, as we've seen. They will always compile and run, and these tests reflect the runtime behavior for applications. So the test suite not only prevents regression, but also documents what the application does for somebody new coming into onto the team. And most importantly, it requires no babysitting. There's no manual intervention. When we use it in the plugin, we click the button and we got a bunch of tests. When we use it in the command line, we ran a command, came back 2 minutes later and got a bunch of tests as well. And it writes tests at scale. One thing I didn't show. So we had asked DiffBlue to go and write tests for the whole application, and it found 100 methods across our application, and for those it has written 82 tests for 82 of those methods. 18 methods were left uncovered, and and I said in the beginning, because we have a computational understanding of the code, where we aren't able to write a test, we will leave behind notes and tips for the developers to explain why we didn't write a test or why weren't we able to write a test. So of the 18 methods for which we haven't written tests, 9 were what we call trivial constructors. So these are constructors which take a value and assign it to a property. There's no point testing the assignment operator in Java. Trivial constructor get tested through other means or anyways. So we don't write tests for them because they just create more noise. 5 of them were things that you typically won't test at all. So main method or callback methods that some frameworks use for configuration. But the interesting bit here is these 4 methods for which we haven't created tests, and of those 3 were the cases where there was some missing observers. So these would be things like a getter or a setter missing on a property, which we need to be able to manipulate to write a really good test for that method. So we will leave a partial test with a to-do note and say, please could you add a getter or a setter, whichever may be necessary, or both, for this property, and run cover again so we can go write tests for that. So that's how Cover not only writes tests for you, but by observing your code and understanding the testability of it, it gives you insight as to how you can make it more testable iteratively. And so we've written these 82 tests. Typically, customers tell us that developers take about 10 to 15 minutes to write a unit test. So 15 minutes, 82 tests, you're talking basically a week worth of developer effort, full-time, just writing unit tests. And DiffBlue has done that for you in 6 minutes. That's 4 seconds per test. And all of those tests, 82 tests, are just as valid, as complete, as regression busting, as the ones I've showed you. And that's the power of Cover. It helps you move fast without breaking things. And that's why our customers love us. We have a great set of customers, from large financial services companies to big tech corps. And we are now also partnering with the major CI providers to provide one-click integration for their customers, so they can adopt DiffBlue easily. So what should you do now? Well, go try it on your own code, and then let us know what you think.
That's great. Thank you, Animesh. So we really hope that you enjoyed the demo. And we've got a number of questions. I'd also like to thank you all for actually giving us some feedback, both in terms of which AI for code products and solutions you're already aware of and what tools you're already using. And also thanks for telling us about your use cases and the pain. So I'm just going to go back to that. So Animesh, I don't know if you've had a chance to actually see the results for that poll. But basically, we had a question which was, which of these issues are you seeing in your organization? What pain are you experiencing? 50% of those polled said code quality issues, but actually the overriding two winners are were developer productivity, which seems to be a motivator of 67% of you, but also joint at the front is also technical debt and application modernization. And obviously we recognize that that is generally a big problem for a programming language like Java. So thank you so much for feeding back on that. Essentially, Animesh, all of the things that you guessed are problems and pains, but certainly developer productivity and technical debt leading to application modernization were the biggest use cases. So
I would encourage you, all of you, to go try it on your code. We leave your contact details as well, including mine, and get in touch, because we see this all the time. We get customers, we actually have all three of those problems as well. So I'm glad that people contributed, and it's good to know.
Yeah, thank you so much for that. So we have some questions, so why don't we fast forward to those. I don't have names, so it's your call to be anonymous. I just want to acknowledge that someone was seeing a green line. I hope you managed to rectify that and to see the actual demo and the presentation. But going on to the first question. The first question is about mocks and how we do it. So someone has asked, could you elaborate, Animesh, on how mocks are actually generated by DiffBlue Cover?
Yeah, so we write what is called pure unit tests. When we run the application, the methods in that sandbox, one of the things that sandbox allows us to do is also intercept any external calls. So these would be calls to the file system, any network calls, third-party libraries, so on and so forth. That analysis helps us understand what needs to be mocked and what call should be allowed to pass through. Once we know that, we use Mockito to write the code that does all the mocking for us. So to give a very specific example, say you had a code that uses the AWS S3 SDK to upload a file to a bucket. The test for that method will mock the S3 client put object, I think that's what it's called, running on memory now, method. It will use Mockito to mock that method so that when your code calls it, it doesn't fall through the S3 library. We just give it a file and the typical mock response. So we'll mock, in that case, we're basically mocking out the behavior of the Amazon S3 SDK, because we're not interested in testing S3 for Amazon. They've probably done it, we hope. In other cases, when you're making API calls to a third party, we will intercept that. We will see the shape of the response you're expecting back from that service, and use Mockito again to create a mocked response, which we will use instead of letting the call fall through. So as a developer, we do exactly what we as developers do when we're writing just unit tests. Whereas we're looking at anything that is not part of the behavior of that method should just be mocked out, because the purpose of the unit test is to just test the logic in that method. We do work with some customers sometimes, and this is, I've started to see this pattern now in the industry, where we are kind of writing a hybrid unit test, which is not a pure unit test, but not a full-blown integration test either. So you probably, someone on the call probably come across things like test containers, where when you are testing a piece of code that interfaces with the database, you're not mocking out those database calls, you're just letting them run through to an in-memory database. When Cover sees those that kind of code, it actually mocks it out. So that's why I said at the begin with, we will write pure unit test. Hopefully that answers the question. If not, please follow through and I'll take it.
Feel free to follow through in the Q&A. So the next one's about CI pipelines. We're really glad to get this one because this is a distinguishing, a differentiator for DiffBlue cover. So obviously you can use it for inner loop local testing, but one of the distinguishing things is that DiffBlue generates unit test suites, multiple test cases at scale. And one of the most powerful ways in which it does this is to integrate with CI pipelines. So essentially, someone is asking about a specific CI pipeline, and it's Bitbucket. So the question is there a plugin to integrate with Bitbucket CI/CD pipeline?
There's not a one-click integration yet, like we have for GitHub Actions and GitLab. But essentially, what you need to do is take the command line interface and configure it. It takes about 15 minutes to do it. We've done it for Bitbuckets before. But like I said, if it's an environment that can run a command line, it's an environment that can run cover because all of the AI is happening on device.
And yeah, do let us know, follow up with another question. And if others are interested in Bitbucket, please just ask us a question, and or even just put in the comments that you're interested in Bitbucket and you use that at your workplace. We'd love to hear about that. Naturally, we are always looking to improve developer experience and also developer efficiency and the efficiencies of teams. And so that CI pipeline test automation is pretty critical for actually going beyond individual developer productivity to boosting the productivity of entire development teams. And how? On pull requests, and that's actually what the next question is. So someone is saying, I assume that the PR piece only works with Git, and when you say that, I assume you mean GitHub. Is that correct? No. Animesh.
No, that is an excellent. It's a pause for thought actually, because I'm yet to work with a customer which does not use Git for source control. So
Right.
it's not limited to GitHub. Any kind of platform that allows you to have a Git repository and you can have merge requests or pull requests, it will work just fine. I'm gonna say I think it will work with other source control as well, because the input to the this patch mode that we use in the let me actually go back a step and explain how it works. So the PR integration, the way that it works, when we use the CLI here, we triggered the test writing at application level. So it's basically going and looking at the code and just writing the whole test again. If you run this again after having written baseline test, Cover will just simply go and rewrite those tests, because that's what we're asking in this command. There is a different command that we use in a CI integration, which we call patch mode, where what it's looking at is the git diff patch that is submitted for that pull request or merge request if using GitLab or other platforms. That git diff, that diff format is a standard Unix format. So any kind of source control system that can produce that diff patch in the standard Unix format will work just as fine with Cover. So I'm going to answer a question with a yes, with the caveat that I have not yet used Cover on a source control system that's not Git, but I think it should work just fine. I would love to know what source control system you're using, and then I'll probably go and test it out myself after the call.
Yeah, great question, and a really good answer as well. So yeah, do tell us what you're using. That would be of great interest to us. We'd love the feedback. So moving on to IDEs and what IDE you use. So we've got someone that says most of our developers use Eclipse instead of IntelliJ. Any plans to provide an Eclipse plugin? Yeah. So we work with Eclipse, but Animesh will explain more.
So a fully blown first party integration out of the box, like we have for IntelliJ, is on the product roadmap for Eclipse. While we wait for that, there is a solution which allows you to configure Eclipse to trigger the command line every time you want to write a test. So you get the similar kind of behavior where while you're in your Eclipse IDE, you can trigger a custom run, and then that gets piped through to your cover CLI. It's not the nice splashy user experience that you get from IntelliJ, but if you must use it today for Eclipse, there is a way to make it work, and a proper Eclipse plugin is on the roadmap as well.
Yeah, I mean, I think in most developer surveys for Java, Eclipse is still second or third most used IDE. So yeah, tell us what you use, tell us which business you're from. If you've got a team that uses Eclipse, we'd really love to know about that. And thank you for the question. I also want to acknowledge Sriram also asked the question about I'd like to know what support for other IDs there is apart from IntelliJ. So related question.
Yeah, at the moment, the plugin is IntelliJ only. We are looking at, on the roadmap, we have currently Visual Studio Code and Eclipse. Which IDE are you using, Sriram? I've started hearing a lot of people using the Spring Test Suite as well. So yeah, I would like to know actually. If you use, the more information we can get from the market, it helps us prioritize these things. So yeah, please go try cover. Get in touch with us saying I really like it, but I can't use it in my ID, and then we'll make sure we can get it to you very quickly.
Absolutely. These are the things that help to inform our roadmap. And like most companies, there's a roadmap. But really what we want to be is informed by our users and our prospects about what you'd like to see next from us. So we really do encourage you to get in touch with us, either here in the session or follow up in our community forum. So the next question, sorry.
We do have really good developer velocity because we release twice a month. So we're pretty good at responding to market feedback.
Next question. Will DiffBlue cover handle EJB 2.0?
I will have to look it up, that specific version. I can't say off the top of my head, but can we drop a link in the chat for everyone, Zoe, by any chance?
We can. What, to your email or?
No, so on our documentation website, docs.diffblue.com,
Yep.
we have a specification and requirements page which lists all of the different libraries and frameworks that we support. So we'll drop that link in here. Zoe, I'm going to send it to you.
I've got it actually. Just dropping it into the chat. I was actually planning to do so. Here's one I prepared earlier. So yeah, essentially this is the prerequisites and all of the specs for DiffBlue cover. Whether you're using DiffBlue cover or interested in interacting with DiffBlue cover via plugin or CLI, it covers test frameworks, it covers all of the different versions of Spring and other dependencies. So hopefully, regardless of what you have in terms of your stack setup, hopefully we support it. And if we don't, we'd really love to hear from you so that we can prioritize supporting your tech stack in terms of our product roadmap.
Yeah, so just to add to that, so anybody that has that question, please visit that link. Just to that specific question on EJB. I know that I don't know the exact version, but I do know that we have launched limited support, preliminary support for Jakarta, and there's a lot more work going on to get it fully baked into the product. So to see whether it will work with your exact code, again, I'll point you to that QR code. Try it on your code. That's the best way to know if cover's gonna how cover will work on your code.
Not sure exactly. This is clearly a follow-up question. Someone who, let's see. Sorry, you are coming up as anonymous, but you basically said to clarify, we are stuck with SVN for the foreseeable future.
That's the source control one. Okay, yeah. I think that should work because SVN can produce a diff file in that Unix format, so it should be fine.
We also have some feedback and comment from Darren Wolf. Thanks for the comment. Darren says, a large part of our Java libraries are back-end, no UI. And they have a lot of different JDBC database connections, each reaching out to several database DB schemas. Our code does a lot of inline queries, and I'm wondering what kind of techniques are best or commonly used in order to establish and then grow metadata necessary to support compile time unit testing execution. So that's the first question, and the second one is, can you offer suggestions or share some best common strategies DiffBlue could work well with?
Okay, I'll take the second one first
Yeah.
because it's the shorter answer for that. So typically, what we see is because DiffBlue is trying to write pure unit tests, it doesn't do integration test or functional tests. So what it's trying to do, and it works really well out of the box on applications which are layered. So anything that's an MVC style application where you can clearly separate out the repository layer from the controller layer and just focus on just mock things out. It works excellent there because it out of the box because it doesn't need to do much to separate things out. Where things are a lot more spaghetti, then what it would do is it will try its best to write test cases, and where it can't, it will produce these code quality insights I talked about, which we briefly looked at as well. So things like these output codes that we see. And those output codes, we actually have a third part of the solution, which we didn't look at today, but I will show it to you now. So once you've written a bunch of tests, so let's say you picked an application, ask it to write tests. DiffBlue will go and write some tests, produce some testability insights. Now you're not going to go and read through all of this console output. So the better way to do this is a tool that we have, which is part of the larger DiffBlue solution, and that is DiffBlue cover reports. And that's what it looks like. It gives you this nice UI, doing basically coverage analytics, tells you the coverage that you receive from DiffBlue, the total coverage in the application. So that would be DiffBlue coverage plus anything you have from developer written tests. But the fun stuff starts happening when you look at the coverage map. So you can start looking at, okay, where is the coverage lacking in my application? So let's say we picked up the kind of application where it's more spaghetti. So what you would see is some parts of it will be really well covered, and some parts won't be that well covered, and there'll be a lot of output codes. This, for example, in this application could be the compliance part, which has a lot of output codes. So you can drill down there and then move to the coverage detail page to understand why wasn't DiffBlue able to write a test and what could you do to improve the testability of that part piecemeal. So here, if we look at this check account compliance method, it's got 6 lines of code, 4 of them are not covered. Sounds like a very important method. It's called check compliance. And DiffBlue has left an output code, the why it didn't happen. You click through the output code and it will help you understand the root cause that's affecting the testability of that piece of code. What could you do to address that? What are the built-in features in Cover that can automatically perhaps try to do something for you? So that's one part of how the techniques that Cover will suggest to start making your code more testable. So now go back to the second question, what kind of application does Cover really work well with? Out of the box, layered applications where components are very easy to separate out. Cover will just excellent work out of the box. Any kind of other application which are really enmeshed together, and to write unit tests, you need to do a lot of pre-test setup and post-test teardown. There you will need to help Cover understand how to maybe instantiate test objects properly, give it some factory methods to run so that it can create test data effectively, so on and so forth. So that was the second question. I hope I've answered it, and I haven't gone into too much detail. What was the first question, Zoe, again, please?
Question was related to basically Darren was saying, I'm wondering what kind of techniques are best or commonly used in order to establish and then grow metadata, the metadata that's necessary to support compile time unit testing execution?
Right. Okay. So actually, to be honest, both questions have a similar answer, basically. So because Cover is running your code to be able to write tests, these output codes are the biggest metadata that we generate as a tool to help both you and us understand how can this piece of code be tested. And to address these output codes, there are a lot of functionality customization built into Cover. One of the features called custom inputs, which allows you to specify the right kind of test data. You also have the ability to specify a custom base class for DiffBlue test, where you can specify all sorts of pre-test configuration or post-test teardown behavior, and then tell Cover that every time you write a test, inherit from this class, and it will do so. So there's quite a lot of techniques available, but the core point and the central point where the metadata that we focus on to improve the coverage and testability are these output codes.
Okay. So just moving on, we have some feedback both from Shriram and also Darren Wolf. So Shriram uses Eclipse. We did ask, he answered. And Darren says, as a team, we encourage and use Eclipse, but personally prefers NetBeans and Eclipse. So that's the feedback on that. How to engage your team in case if our team is interested in proceeding further. So I think this is a question about how can we facilitate a team demo, really, or what other options are there for evaluating DiffBlue Cover?
Yeah, so the first thing I would suggest is that you go and try Cover on your code. And let's set up a demo for your team so I can demonstrate the capability of Cover to the rest of your team members. Typically, after that demo, there are three options to evaluate Cover. You can continue on the Teams trial and then go and buy a Teams license. Or you can do a proof of value, which is a 2-week POC where you and I would work together, understand your business problems, and then we'll try Cover on some of your applications to help you build a business case for a larger adoption of Cover internally. So that's the second option. And there's a third option which is a 90-day pilot license, which you can buy to use Cover. And in the difference between the POV and the pilot licenses, in the POV, we will only look at the out-of-box coverage. So we will point Cover at an application, see what you got on the first run, and we'll try to build a business case based on that. In the pilot, because we've got more time, we've got about 90 days, we will not just look at the first run, we'll address some of the output codes, so you can see how that iterative value add works as well. So three options. You can try the free trial. We can do a managed POV together, 2 weeks, or we can do a longer pilot where we work together and try to build a deeper business case over time.
Thank you. And let's see, we have one more question. Will this plugin send the actual source code to DiffBlue Cover to generate the tests? And how can I make sure my source code is secure? This is a common question and a common concern about AI assistance and full software testing solutions like DiffBlue Cover. So yeah, we did mention it, and Animesh will dive in about the security and privacy of your code and IP when using DiffBlue Cover.
Yeah, so DiffBlue does not send your source code anywhere. All of that analysis happens entirely locally. The 3 network calls that a DiffBlue Teams product makes, and I specify the Teams product because in enterprise license, we have a truly offline mode where you can run DiffBlue in a cave. Doesn't need internet at all. But in the Teams edition, you have there's a license call that we make to a license service. That's just the date. We're basically sending your license key and making sure it's still active. So still no source code gets sent. Then we have, if you're using the plugin, we have error reporting enabled for plugin, and that goes to our error reporting portal. Again, this is all about our internal logs. No source code is being sent. And finally, we collect some aggregated telemetry. So, for example, through the course of this demo, Diplo would have collected that I clicked a plugin at this time and it produced these many tests, so on and so forth. That's the third data that gets sent. You can find on a documentation website, we have documented the every single data item that we collect as part of this process. You'll find that in a privacy policy. But we don't collect source code regardless of whether you use the free edition, the Teams edition, the Enterprise edition. The Enterprise edition just has the nice benefit that you can run it in an air-gapped system completely offline.
Okay. Hoping that answers all of the questions. We've actually got to the end of our written questions in the Q&A. I'd like to thank you all for your interest in DiffBlueCover and in AI for code solutions in general. You're really helping to drive this area where there are huge potential benefits in terms of being able to augment developers. And certainly what we're trying to do is to enable you all to build faster and build cool products and applications and spend less time unit testing. But unit testing is foundational when it comes to software testing. It's necessary, but why not hand off to DiffBlueCover essentially and get that feedback and that verification of your code changes much faster than any other way possible. So in the chat, I have dropped in links. The best thing is we're not a salesy organization. The best thing is to just try the product out for yourself. We really appreciate the feedback about which IDEs you use, and certainly we will feed that back to our product team. And yeah, I think that is this session drawing to a close. We really appreciate you joining us for this webinar. There will be more to come, not just demos, but actual conversations about the AI for code space. We really hope to see you again in the future. And do try Cover for yourself. And we'd love to hear the feedback that you have about developer experience or about integrations or anything. And you can join us in our community forum to feedback directly. But also Animesh is just put on the screen. So if you have any further questions, or if you are interested in doing a team trial evaluation or a proof of value, which is our POC, please reach out to Animesh. There's his email on the screen. You can also use the QR code to actually fast track to a trial. And we really hope you get on well with DiffBlueCover. Thank you so much for your interest. Thank you for joining wherever you are in the world. And we hope to see you again on one of our webinars very soon.
Thank you very much. I would please go try it. Love to hear your feedback if you love it, and would especially appreciate your feedback if you don't. Thank you very much.
Absolutely. Yeah. And also thank you very much for feeding back which other developer tooling that you are using and which other tooling you're interested in or you've heard of. We know that you've got choices. We hope that you will get on really well with DiffBlueCover. It certainly enables you to unit test and rather than the very valid iterative process that you might go through with coding assistants, they do assist. We sit comfortably alongside them. We're not trying to do exactly the same, but actually if you want unit testing that unit test generation, maintenance as you make changes to your code, and for tests to be generated at scale, DiffBlueCover is your solution. So thank you so much for your interest. And we'll end this session. It will be available on replay very soon. So for all of you that missed it, don't worry. You'll be able to watch it very, very soon. Thank you so much. Good evening, good afternoon. And if anyone's still in the morning, good morning. I hope you have a great day. Thank you.
Thank you very much. Goodbye.